Hello students. So in this session, mainly we are going to discuss about a vector form of reflection of a light. So in the last session already, we have discussed what we mean by reflection. Reflection means the phenomena of bending back to the same medium of light rays is called what? That is called the reflection. Okay. So here I have taken the diagram. So I'm representing this as a this is none but so here it is an incident ray. Okay na. So here actually it is an incident ray and actually so here it is a reflected ray and this unit vector I'm representing this as the e suffix of I cap and this reflected vector I'm taking reflected unit vector I'm taking as the e suffix of r bar and actually we know what is the loss of reflection here now? The loss of reflection is the angle of incidence is equal to angle of reflection is equal to theta. So here angle of incidence and angle of reflection both are same or both are different? Both are same. Okay. So here it is this is the incident ray and here it is a reflected ray. So it is the E suffix of I cap. So here it is the E suffix of R cap. And so here I am taking this is the T cap. T cap is the unit vector along the tangent and here M cap is number that is a unit I am representing E suffix of I cap. So what do you mean by E suffix of I cap? E suffix of I cap is number that is a uh, unit vector unit vector of incident light ray. Okay, that is a unit vector of incident light rays, incident light ray. And what does E suffix of R cap stands for? E suffix of R cap stands for that is a unit vector of reflected light ray. Unit vector of reflected light ray. Unit vector of this particular reflected light ray. Okay. And here what does n cap stands for? N cap stands for that is the unit vector along the normal. So n cap stands for that is the unit vector along the normal. Along the normal. And what does t cap stands for? T cap stands for that is the unit vector along the tangent. Unit vector along the tangent means that is along the tangent means I am taking that is along the x-axis so e suffix of I cap stands for unit vector of incident ray and e suffix of r cap stands for the unit vector of reflected ray and n cap stands for the unit vector along the normal and t cap stands for the unit vector along the tangent. Now here if you look at this particular diagram very carefully, so here this incident ray. So here this incident ray E suffix of I actually it is lying in which quadrant? That is lying in the fourth quadrant. That is lying in the fourth quadrant. So here we know if this angle is theta, this angle is theta. So what about this angle here now? This angle also will be equal to theta. Now, if you resolve this particular e suffix of I into two components, so here you are getting this will be e suffix of I cos theta, e suffix of I cap, e suffix of I cap cos theta followed by the n cap. That too I have to take minus. Why? Because that is a negative n cap direction. And so here it will be nothing but what? So here it will be E suffix of I cap followed by the sine theta followed by the T cap. E suffix of I cap followed by the sine theta followed by the T cap. Okay. So similarly, if you can resolve this particular E suffix of R into two components, so E suffix of R cap into two components. If you resolve into two components, so here what you are getting here now. So here it will be E suffix of R cap followed by the cos theta followed by the N cap. So here it will be nothing but that is the E suffix of R cap followed by the sine theta followed by the T cap. So if at all, if I'm writing as a vector, okay, if at all, if I'm writing as a vector, so what happens? So if I'm representing as a vector, so what happens now? E suffix of I bar, E suffix of I bar can be taken as a mod of, that is a negative of mod of e suffix of I cap followed by the cos theta followed by the n cap and next followed by the plus mod of e suffix of t cap followed by the sine theta followed by the t cap. Okay, no, sorry, it is the e suffix of I cap. And we know e suffix of I cap is a unit vector. E suffix of I cap is a unit vector. So what is the magnitude of this particular unit vector? The magnitude of unit vector is always equal to 1. So here I can take this is equal to 1 here now. That's the minus of a cos theta followed by the n cap plus again, so one more unit vector, and we know the magnitude of unit vector is equal to 1. So finally, what happens here? Know that the sine theta followed by the t cap. This is the value of e suffix of I bar. E suffix of I bar is equal to what is the value here now? That is the minus of a cos theta followed by the n cap plus sine theta followed by the t cap. If you can represent a reflected ray as a vector, so what happens? E suffix of r bar is equal to, if you can see here, I can write that is the mod of e suffix of r cap followed by the cos theta followed by the n cap plus here what I'm getting here now e suffix of r cap the mod of it so followed by the sine theta followed by the t cap sine theta followed by the t cap and we know just now I said so e suffix of r cap is a unit vector and what is the magnitude of this particular unit vector is equal to 1 here. So here I can take e suffix of r bar is equal to the cos theta followed by the n cap plus sine theta followed by the t cap. So here I am representing, so here it is another equation. So let us name this as this is an equation 1 here and here it is equation 2. So what I am doing here now, equation 2 minus of equation 1. So here it will be e suffix of r bar minus of e suffix of I bar is equal to cos theta followed by the n cap plus sine theta followed by the t cap negative of this. So minus, so what I'm getting here now that the plus cos theta followed by the n cap and minus sine theta followed by the t cap. So this value and this value will be getting cancelled and these two they will be getting added. So finally what happens here now e suffix of r bar minus of e suffix of I bar is equal to the value what you are getting here is none but as the 2 cos theta followed by the n cap 2 cos theta followed by the n cap. So this I am taking this is an equation 3. So now here okay, you got this is an equation 3 here. So if you look at this particular diagram, in this diagram, so what is the angle between E suffix of I bar and theta? If you look at this particular diagram once again, okay, so here actually incident ray is lying in this particular direction, E suffix of I, and this angle is then what this is on theta. So here it is a normal. Actually, we know from here to here, this angle will be equal to 180 degrees. So, what is the angle between the normal as well as a incident light ray? Normal as well as a incident light ray, we are getting this as a 180 minus of theta, 180 minus of theta. So, the angle between the normal as well as a incident vector. So, what I'm getting here that is a 180 minus of theta. So, here I can take e suffix of I cap dot n cap is equal to a bar dot b bar. So what is the formula for it? That is the mod of a bar, mod of b bar followed by cos theta. So mod of e suffix of I cap. So mod of n cap. So followed by the cos of 180 minus of a theta. And we know cos of 180 minus of theta, what is the value now? That is the minus of a cos theta. So this value will be coming out to be like e suffix of I cap dot n cap is equal to what is the value here now? That's the minus of a cos theta. And if you are substituting the value of a cos theta, I'm taking this as a fourth equation. So if you're substituting this value of a cos theta in the third equation, so what I'm getting here now, fourth equation in third equation. So here I'm getting here now E suffix of r bar minus e suffix of I bar is equal to 2 times of, actually what the value of a cos theta, minus of e suffix of I cap dot n cap multiplied by n cap. So here what happens now, e suffix of r bar minus of e suffix of I bar is equal to, that is the minus of 2 times of e suffix of I cap dot n cap multiplied by the n cap. So actually this is a vector representation of reflected light ray. So here I can write down the final formula will be e suffix of r bar is equal to e suffix of I bar minus 2 times of e suffix of I bar dot n bar multiplied by n bar. So this is the reflected form of a vector. Okay, this is a reflected form of a vector. Take down from up to here.